Okay, hopefully third time is a charm here. This is my third time trying to get this live stream started. I'm using software that is not super familiar to me, so we'll see how this goes. Okay, everyone, welcome. Today is Sunday, May 4th, Star Wars Day. May the 4th be with you. Today, here on AeroSafe, we are talking about weather from the perspective of a general aviation pilot. So my name is Erica Gilbert. I'm a flight instructor located in central Kentucky. And here we're looking at, again, the weather from a general aviation pilot's perspective. Most of us are flying piston aircraft, relatively low and slow. Some of us may be VFR only. Others might have our instrument rating, but a large majority of us are also flying aircraft that are not certified for flight in zone on icing. So we have to be very mindful of those conditions if we do fly into the clouds. So today we're going to be looking at areas of VFR weather and areas of IFR weather, and then the potential hazards that exist within both of those areas. So let's start by looking at the AeroSafe weather brief checklist. Now, this checklist is something that I developed about a year ago, and it is something that is free and available for you at gilbertaviation.com/AeroSafe. So this weather brief checklist walks you through all of the required 91103 pre-flight action requirements. So we have that mnemonic that we use to remember that, which is NW craft, NOTAMs weather, known ATC delays, runways, alternates fuel requirements, and takeoff and landing data. And so by using this checklist, you can make sure that you are covering all of the items necessary to fulfill that 91103 pre-flight action requirements. But the biggest piece that is confusing to some people is the weather reports and forecasts. So then on the second page, we break down those weather reports and forecasts that you should be looking at as a prudent pilot to make sure that you're looking at all the information available and making good decisions. So it starts with the surface analysis chart and prog charts and ends with 1-800-weather brief. So calling an actual briefer, a real person, asking questions, and making sure that you're filling in any holes in your knowledge. So the reason why we do this is because weather is a causal or contributing factor in far too many general aviation accidents. So the goal here is to help provide you with the weather knowledge, weather decision making, and all the pieces and little tips and tricks along the way to help you make more informed and confident decisions as a pilot. So, being that the weather brief checklist starts with the surface analysis chart, that is where we will start as well. Alrighty. Here is our surface analysis. By the way, for those in the chat, if you have questions along the way, or when we get to looking a little bit more in depth at the weather, if you have a route coming up that you want me to look at, please feel free to drop that in the chat and we'll look at it together. So I like to start looking at the surface analysis by going east to west. This chart is valid today, starting at 1500 Zulu, and it was updated at 1637, which is just about the 45 minutes or so ago. Okay, on the East Coast, we have a big stationary front going up from over Canada down into Pennsylvania, and then another one going down into the Gulf of Mexico. There is also low pressure over Kentucky, Ohio, Indiana area. So low pressure, and this would be a check ride question. How does air move around a low pressure system? Well, air moves around a low pressure system counterclockwise, in and up. So at some point, these two different fronts, they're both stationary fronts now, but they would have been previously a cold front here in the southeast and then a warm front in the northeast. The presence of this low pressure system created this cyclonic action, this counterclockwise movement, and pushed the cold front into the warm front. As a result, we see an occluded front here, depicted by the purple triangles, and semicircles. So, the definition of an occluded front is where a faster moving cold front has caught up with a slower moving warm front. And oftentimes, we see that a low pressure system is the cause for that. Interesting about this occluded front, though, is that it's not just an occluded front. In between the semicircles, the half circles, and the triangles, there's also a dashed line, and that indicates a frontolysis. A frontolysis is a front that is weakening, it's losing strength, meaning that the air is kind of mixing in together, and the differentiation between those air masses is becoming less noticeable. As a result, we would expect to see similar weather to a strong occluded front, just that the weather isn't going to be as strong. And that is the case here. We see some precipitation up in northern Indiana, Ohio, and Illinois. And then also here today in Lexington, where we're kind of at the center of the low, there is a lot of vertical development of the clouds. I'm looking at the window right now, and they are towering cumulus. There hasn't really been any convective activity today, at least not where I am. I know that there has been some near me, but that's the weather that we're seeing today. On the back side of that front, we've got high pressure in the west, well, in the Midwest, from Minnesota down into Texas, and that should mean that we get a little bit better weather than we've been seeing the last couple days in that area. And then, as is normal for this time of year in the spring, out in the far west, we see a mix of different pressures and some cold fronts as well. So some not super strong, but present enough to depict different high and low pressure systems, along with troughs. So these dashed orange lines indicate a trough, which is an elongated area of low pressure. Low pressure is rising air, right? We talked about how this low pressure over here is going counterclockwise in and up. It's rising air, so it's not stable, it's unstable air. Where we see instability in air masses, we tend to see the development of clouds, sometimes pretty extensive vertical development. And that's kind of going on around here as well. So that is our surface analysis chart. I would say things to look out for in the next couple days are probably, what's going on with this occluded front in the next few hours. And then this cold front that's coming down in from Canada, I'll be interested to see what's going on there. I would guess where we see the southern part of this cold front and this warm front here, there's probably a low pressure system up there that's making those kind of mix and turn into an occluded front at the top. That would be my guess. All right, so that's our surface analysis chart. And again, this chart is a depiction of all the frontal and pressure systems across the surface of the US. And this is going to show us kind of the reason why for most of the weather that we're going to see as we move forward. If we go back to the AeroSafe weather brief checklist, the next thing that the checklist guides us to look at are Airmets and SIGMETs. So we're going to use the interactive map on 1-800-weatherbrief.com or a flight service run by the company Leidos. We are going to use this interactive map to help give us an idea because it depicts all these Airmets and SIGMETs graphically. We're going to start with the SIGMETs. We'll start out west. So where we saw those mix of different pressure and frontal systems out in the west, we see kind of some corresponding convective activity. The dashed area that's grayed in is a convective outlook, meaning that the ingredients exist for thunderstorm to develop in that area. They just aren't so sure exactly where it's going to happen. So it isn't unsafe to fly in a convective outlook. However, you want to be very mindful of the times that it's active and then look within your local area and along your route of flight to make sure Make super sure that you understand the conditions that are likely to show up, and you need to have a plan in case that does happen. So that's the convective outlook. And then in the white boxes, we have convective segments, and we've got 5 in the area. Let's look at this one. This one looks the most exciting. Okay. Over Utah, southwest Utah, we have a convective segment, an area of embedded thunderstorms moving little. Tops go up to 31,000. So they said it's not moving very much. Let's play the pointer here and see what's going on. Yeah, they're not moving a whole lot, are they? And they're moving to the northwest. That's interesting. This big one over Southern California and Nevada, same thing. Area of embedded thunderstorms moving little, tops to 330. Now, an embedded thunderstorm means that the storm cell is within a cloud, which means that you can't see it. And that can make them especially dangerous because you can't dodge around them, you can't fly between them because you don't know where they are. Unless you have an onboard weather radar. And I don't know of any light GA aircraft that have onboard weather radar. Not to say that there aren't any, but I don't know of any. Typically, it's not until you're in a turbine that you might have an onboard weather radar. So embedded thunderstorms are particularly dangerous because you can't see them. And I would bet that all of these, well, this one doesn't say embedded. Thunderstorms moving little, thunderstorms moving little, and thunderstorms moving little. As you can see, though, there are some areas of precipitation that are not within the segment. These segments and convective outlooks are drawn by people, so the lines are somewhat arbitrary, and the weather doesn't know the boundaries of an airmet or a segment. So it's very likely, at least in my part of the world, if I saw a segment right here and like this radar return, my where I am, I would say, okay, well, that's likely to also become convective activity. So I'd want to look for that. Really, all of the stuff within here would be likely to become convective. Moving easterly, we have another convective outlook over eastern Kentucky. Again, saying that all the ingredients exist for a thunderstorm to form, which is another question you'll be asked about on every check ride that you take from now until the end of time. What are the ingredients for a thunderstorm to form? Those 3 ingredients, hopefully you know the answer, but those 3 ingredients are sufficient moisture, unstable lapse rate, and lifting action. So the convective outlook tells us all the ingredients are there. It's likely something is going to form, but we just don't know exactly where. And then the segment tells us there is currently convective activity in that area. Area of embedded thunderstorms moving from the south at 25 knots, tops to flight level 270. So you'd want to stay quite a bit of ways away from that. And again, all of this stuff is being caused by that low pressure system over Kentucky and the occluded front, which occluded frontalysis. Okay, make sure there's no questions. No questions. Cool. All right, along the East Coast, we've got widespread area of convective segment. Now, most of this is over the ocean, and I'm assuming that most of us are not flying over the ocean, unless maybe someone's headed down to the Bahamas, in which case you'd want to be very mindful of this. So on the far East Coast, looks like kind of southeast New York, down to the tip of North Carolina, we've got convective segment. Embedded thunderstorms from 180 at 30 knots. So it's moving to the north. Then South Florida, we've got some segments as well. Embedded thunderstorms moving from the west at 35 knots, top to flight level 350. So that's pretty high tops there across southern Florida. Is this Naples here? Yeah. Um, I'd wanna be quite a bit away from that flight level 350. You'd wanna be at least 35 miles away. And then we've got convective sigmet over northern Florida, also moving from the west at 25 knots, also pretty high. It's not something that you'd wanna be in or near, so be mindful of that, maybe wait a little bit for that to dissipate or to move over the ocean as the day goes on. So that is our sigmets. Okay. Next, we'll look at our Airmets. We're going to look at Airmet Tangos first. Airmet Tangos are issued primarily what we recognize with them is turbulence. They're issued for turbulence. However, Airmet Tangos can also be issued for a low level wind shear and sustained surface winds of 30 knots or greater. The green Airmets depicted here are for high level or high turbulence, so over flight level 180. So in the flight levels, where most of us are not flying. So, not a huge deal to us. They don't really come into play with decision making. However, they do give you an indication of the stability of the atmosphere and what's going on in the flight levels. Off the coast of California, it is very windy. There is an Airmet Tango for those really high sustained surface winds greater than 30 knots. Let's zoom in here a little bit, see if that's actually making its way into the land. Monterey does not have high winds now, but I closed that too early. I saw something on the TAF. On the TAF, they're forecasting winds gusting to 20 knots a little bit later today. Are there really not many? Okay. Arcata, is that how you say that? Arcata? I'm not sure how that's said. Has winds on the moderate side, and then this afternoon, definitely expected to get a little stronger with wind shear at 1,500 feet coming from the north, 35 knots. So 45 knots, that's pretty steep. What about down here? Pretty strong wind there, but not super strong. Okay. So just be mindful, California. It's very likely you're going to get strong winds as that moves on. Excuse me. Okay, continuing on with Airmets. So none of these are, particularly worrisome. We don't have sustained surface winds or low level turbulence or low level wind shear across anywhere in the country. So really the biggest thing to be mindful of here is that sustained surface winds of more than 30 knots off the coast of California. Let's look though at Airmet Sierras. Airmet Sierras are issued when you cannot see. So widespread areas of IFR conditions or mountain obscuration, and normally they overlap. So up in the Northeast, associated with those two stationary fronts and the occluded front, we see both. We see a large area of IFR conditions and mountain obscuration. So not ideal. We'll look at the Airmet Zulu next to see if there's icing involved as well. If so, that would be a no-go situation. In addition to looking to see if you had convective over your route of flight. In the west, same thing. So in mountainous terrain here, we've got mountain obscuration and then some areas of IFR conditions as well. So obviously, if you are a VFR only pilot, you got to stay away from Airmet Sierras. You have to be able to see as a VFR pilot, right? You've got to have a reference to the ground. You can't be in a cloud, and you have to maintain your VFR cloud clearance requirements. So class Echo 10,000 and below, check ride question. What are the VFR weather minimums there? This is something that you need to know. You've got to have memorized. The VFR weather minimums below 10,000 in class Echo is 3 miles of visibility, 500 feet below clouds, 1,000 above, and 2,000 horizontally. That's the absolute minimum that you need to be VFR. However, it's much safer to have greater minimums than that. You don't want to be flying around clouds when you don't know if it may close in on you. So you need to make sure you got plenty of clearance. So again, concern with these is if you are a VFR only pilot, you'd want to stay away from them. Add to it potentially some Airmet Zulus, which same areas, which makes sense because the Airmet Zulus are for freezing or icing conditions. Now, in order for icing conditions to exist, we've got to have visible moisture, which could be a cloud or precipitation, or fog, which is a cloud, it's just a low level cloud, and temperature near or below freezing. So we'll look at these icing Airmets. This more northeasterly one has the base at the freezing level, which is somewhere between 9,000 and 12,000 here, and the top's up to 22,000. Then in kind of the Midwest area, we've got another one. Freezing level's a little bit lower here, which is interesting because it's farther south, between 6,000 and 9,000, tops to 20,000, moderate severity icing. And then in the west here, we've got 7,000 feet of range of the freezing level. So from 5,000 to 12,000, tops to 20,000. So if you are, I mean, that's a huge range, 7,000 feet. This is mountainous area. So, this freezing level might be below the terrain in some parts. In fact, it is below the terrain in some parts. So if you're flying in a cloud in this area, you're pretty much going to need to have certification for flight into known icing, because if you're in a cloud and you're above the freezing level, you're very likely, it's pretty much certain that you will get structural icing, which is no good. So we'll overlay the Airmet Zulu with the Sierras again, and you can see there is a lot of overlap here. So a lot of these IFR areas do have freezing conditions, or on the East Coast in particular, if you turn on the SIGMETs, a lot of those IFR areas are related to convective activity. So, yucky. Let's take a second to look at the freezing levels. In my pocket, 8,000 feet. Further south, 12,000. 12,000 here, 8,000 here, 12,000, and 4 to 5,000 within that. So based on the freezing levels, I would think that not a whole lot of the bases of this Airmet, not a whole lot of area has the bases at 5,000. So you'd have to look at your route in particular if you were flying in this area, determine where the freezing level is, make sure that it's well above the cruise altitude that you've already selected, and that you have a way out if necessary. But if you're down here in Utah, and well, you want to make sure that you don't have one of those convective SIGMETs over you. Let's say Nevada. Let's say you're in Nevada, you're flying in the clouds. You want to make sure that you're above the freezing level and that you have a place to get out if you need to. All right, that is the Airmets and the SIGMETs. We'll look at center weather advisories. We've got one over the four corners. This are thunderstorms moving from the southeast at 15 knots, tops to flight level 320. I learned last week that these center weather advisories can be issued whenever versus SIGMETs, which are issued 55th minute of the hour, I think, which is cool. We have no severe weather watches or warnings, which is good. The AeroSafe weather brief checklist tells us what we should be looking at next. And I'm going to change my window here so you can see that. So we've looked at the surface analysis chart. We're going to look at prog charts last. We looked at Airmets and SIGMETs. Next, we'll look at the Pyreps to see if the reported conditions by pilots verifies all the stuff that we've looked at with the advisory products. One of the things I really like about this interactive map on Flight Service is the layers. and being able to see everything depicted graphically. The one thing I wish we were able to do is split this up by altitudes. So, 0 to 5,000, 5 to 10, 10 to 15, 15 to 20, or even if we could just do 18 and above or 18 and below. First thing that stands out to me here is this urgent Pyrep. Looks like there's two of them. Low level wind shear during descent onto runway 9. Okay, don't like that. Here's another one. Low level wind shear experienced by an A320. So they're probably trying to land in the yuck. Lots of turbulence and some icing in the northeast. So here is an icing, light rime icing, -9 during the climb. Another icing here in Kentucky, 11,000 feet. 22T had icing at 8,000 feet. So that makes sense. Moderate icing here, moderate rime in a Boeing 717. Wouldn't want to be there. So there are some Pyreps here that do confirm the conditions that we already thought would exist based off of the Airmets and Sigmets, the advisory products. Oh, wow. Okay. Extreme turbulence. -400 feet. No damage or injuries reported. Type was a Velo. I don't know what that is. I'm going to look it up. Velocity. Oh. Huh. Interesting. I wonder if that's actually what it is. That's pretty cool. Very cool, actually. The extreme turbulence is not very cool, though. So bumpy over there, and other reports of turbulence as well in Airbus 319 at 17,000 feet. Airbus 320, 29,000, and moderate turbulence at 8,000. Light chop at 15,000. So probably some wind coming over the mountains there. What is the wind on the surface? 9 gusting 15, 6 knots, 10 knots. Interesting. Usually on that downwind side of the mountains, there's some mountain wave in the And I'm back. Okay, good. Okay. Pyreps also in the western part of the US that share the same stuff. We've got turbulence and icing pretty up. PC-12 has light turbulence and moderate icing mixed. So Pyreps are great. They help us understand if these advisory products are forecasting information or conditions that do actually exist. So the advisory products are those Sigmets and Airmets. So Pyreps are given by pilots in the airplane. So it's actual pilots with their eyeballs, and they report to ATC or flight service what they're experiencing, and then that information is disseminated to us, helps us make better decisions if we know what pilots are actually experiencing up there. For planning purposes, and the way you use these would be when you obtain a weather briefing along your route of flight, you'd want to look at these and see, do they confirm what you already thought? Are they different from the conditions that you thought were going to be there? And if so, how does that affect your decision making? Are conditions worse than you thought based on the Pyreps? Are they better than you thought? So that's how you want to use these. Now, Sometimes we cannot assume that an absence of Pyreps means that everything is okay. Sometimes an absence of Pyreps means that there are no general aviation pilots flying and making Pyreps. So the presence or absence of Pyreps can sometimes be just as informative as the Pyreps themselves. Down here in South Florida, where we saw convective activity as well, we see Pyreps that support that. Moderate turbulence, moderate turbulence. He said smooth. This guy said smooth below 3,000. Didn't say anything about above 3,000. So that's interesting. This guy, I wonder where he's going. Light turbulence, occasional moderate. So when you generate a weather briefing along your route of flight, this one just popped up. Low level wind shear, plus or minus 10. When you generate a weather briefing for your route of flight, you are going to see these Pyreps. And sometimes if there's adverse conditions, you're going to see a lot of Pyreps. So the way you want to flip through those is look at the Pyreps that are within the altitude at which you're going to fly. See what they're saying. Take also into consideration what type of aircraft that is, because an Airbus 320 or Boeing 737 saying light turbulence at 5,000 feet, that's the way they experience turbulence is going to be a little bit different from the way we experience turbulence, where we are a lot lighter and more subject to the winds. So be mindful of that. Okay. I'm going to change the screen I'm sharing. So we looked at Pyreps. Next, we're going to look at cloud coverage and freezing level. Cloud coverage and freezing level. 1-800-Weather Brief recently changed the way. 1-800-Weather Brief recently changed the way that they provide this information. It used to be that they allowed us to generate the charts right on their website. But now they actually take us to aviationweather.gov. So once you're logged into flight service, if you want to access the two charts we're about to look at, you would hit weather charts at the top, takes you right back to this page. And then decision support graphics is going to take you to that cloud coverage chart and the aviation surface forecast chart. So we're going to click on that and we're going to choose the ones we want. We want GFA, graphical forecast for aviation. And these are forecasts. So they're not current observations. They're only modeled information that forecast into the future. We'll look at the whole US, and I like to look at the clouds first. This cloud coverage chart is really great. It shows you where there might be clear skies. It also shows you where there might be fewer scattered skies, broken or overcast cloud layers. Then further, it gives you cloud bases and cloud tops. It tells you if it's clear above. And then it also incorporates some Airmets, both icing and mountain obscuration. So it combines a lot of really important information, not just for VFR pilots who are having a heyday in the central part of the U.S., all the way from North Dakota down to Texas. Beautiful day for you guys. But it also gives some information to IFR pilots of, can I get above the clouds? And if I'm in the clouds, will I potentially experience icing conditions? This chart is really great. I look at it pretty much every time I fly because I want to see if I'm going to be above the clouds or in them for cruise. So in the west over here, we've already looked at the Airmets, the Sierras, the mountain obscuration, and the Zulus. So no surprise there because we've already seen these. What we can see that's nice is, say, down here in New Mexico, we've got within north, kind of central northwest Mexico, New Mexico, few clouds at 14,000, and above that it's clear. When you look at this chart, there's a lot of information that you can derive from it. So looking at this, we get the bases, so these scattered overcast layers. And then you also get the tops sometimes. So over Colorado here, tops to flight level 350. Then we move into Utah 320, Nevada 330, 240, 320 here. These really high cloud tops tell us that there is a lot of instability in that air parcel. Instability is often related with convective activity. So if we take what we already knew from those convective sigmets that we looked at, we can look at the clouds here and understand what's going on as well. It tells us the same thing, just with a different depiction. So this is a really good way too to look at what's the stability within each of these air masses. So if we go over here to the east, we're going to see a lot of the same stuff, right? Relatively low ceilings, and throughout a lot of this, pretty high tops, because we know there's low pressure. We know there's an occluded front. We know there are cold fronts. We know there's convective sigmets, and we could have guessed that the cloud tops would be really high, but we see that here. Up here in kind of the Virginia area, flight level 370 are the tops, but it's clear above that. So if you can get up there, you won't be in the clouds. North Carolina, flight level 380. Over here in Indiana, 230. Illinois, 310. So, there's no chance of getting above the clouds in that position. Further, you wouldn't really want to, because it's not going to be comfortable. It would be really bumpy. Now, if you could, you'd want to. If you were in a Falcon or a Lear or something, you'd want to get above it. Very similar story down here in Florida, where we saw another convective sigmet, tops to flight level 370. Now, if we move the forecast, let's take it all the way to 12 hours from now. We can see how things might change. So that frontalysis, the occluded frontalysis over my part of the world here, is showing the occluded front weakening in strength. We see those tops kind of start coming down a little bit. The convective activity moves away from Florida and off the east coast of the country. It looks like some still planning to linger around the northeast. For those who are watching, I am looking for comments, so if you have any questions, you can pop them in there. Ask any questions if you've got them. I'll make sure I answer them. So another way I use this chart is if I am intending to take a trip, I might look and see when would be the best window of time to leave. So yes, that's that chart. Okay, so that's the cloud chart, and next we have the aviation surface chart. I'm going to take that too right about now. This chart gives us so stinking much information. We get surface winds, we get surface visibilities, we get IFR Airmets, surface wind Airmets. We have depictions of different types of precipitation. And if you don't know what these depictions are, it could be a bit overwhelming. It definitely could. If you don't know what these depictions are, you can find them in the NOAA Imagery Legend. It should be available on any of whatever electronic flight bag you might use. I'm not seeing the chart that I normally like to see. Here we go. This is what we like. So this chart on the end of this NOAA Imagery Legend that comes off of ForeFlight shows you what these different depictions might mean. So for example, the little one that kind of looks like a lightning bolt relates to thunderstorms. So if we go back to, okay, you can't see that because I forgot to change my screen. Oh wait, am I sharing my entire screen? What am I sharing? Okay. Yes, you saw part of it. Okay. Sorry. Here we go. So this is what I had downloaded here. This NOAA weather data imagery legends and definitions. I can access this on ForeFlight. I don't know about Garmin Pilot, but it's a really great resource. And then we get this box that shows us 100 different depictions that we might see on this chart. So if, for example, we were to look back at that chart, I'm just going to share my whole screen because that's going to be a lot easier. Screen. So if we look back at this chart here, we've got these little red depictions with a dot on top. We'll go back over to the NOAA imagery legend, come scroll down, and here she is right here. And this means a slight or moderate thunderstorm without hail, but with rain and or snow at the observation time. And this might be, you also get the codes that might be depicted in a METAR or a TAF. So TSRA, TSSN, TSPL. Another depiction on the chart here is 3 little lines. Doot, doot, doot. And that is up here at the top. Fog. Sky not discernible. No appreciable change during the past hour. And there are so many different depictions there as well. Four little asterisks. I'm sure you could guess what that is, especially because they're blue. But here they are. Continuous fall of snowflakes, heavy at the time of observation. And if this were depicted on a METAR or TAF, plus SN, plus Sierra Nevada. So, no, not Sierra Nevada. November. Not the beer. Okay, so that is the Aviation Surface forecast chart. I'm going to share just that one with us again. Here we go. So this is a really good one because it gives us so much information. So much information. Tells us about precipitation, tells us about visibilities, and gives us an idea of the surface winds. So, wow, really windy. Really windy. Why is there no Airmet Tango for that? Okay, let's go back to the map because I want to see what the METARs are saying up here about the wind. Up here in North Dakota, what do we have going on? 19 gusting to 26. Mercer County, 27 gusting to 33. 17 gusting 25. Wow. That is really strong winds all the way through there. Wowza. Everywhere has strong wind. Okay, so obviously if you were in that part of the country, you'd want to see if the wind is in line with the runway, and then also is the wind within your personal minimums. So even though it's beautiful VFR clear up there, it's really windy, which I think you guys are used to up in that part of the country. Okay, returning to the weather brief checklist. That's not what I want. At some point. Returning to the weather brief checklist, we are going to look at just a couple more things. So we looked at freezing level. We looked at the aviation surface forecast, cloud coverage. Along your route of flight, you'd want to look at the winds aloft to see how that's going to affect your ground speed, which is going to affect your range. Therefore, you might need to change where you stop for fuel. Maybe you stop sooner. Maybe you don't have to stop at all. That would be really great, wouldn't it? So be very mindful of the winds aloft and the temperatures aloft. We get our cruise performance information based on what the temperature is at our cruise altitude. So make sure you look at that. Make sure you take the wind into account. You'd also, of course, want to look at METARs and TAFs. Make sure that your personal minimums for takeoff and landing are met, along with your route of flight as well. And the last piece you'd want to do is call 1-800 Weather Brief so that you could talk to a real person, a weather briefer, and ask any questions that you may have gotten while you were working through your weather briefing. So that is our general aviation weather brief for today. Let's kind of wrap it up in summary with what we found. I'm going to turn on all of the Airmets and SIGMETs. I'm going to turn off the freezing levels though. Okay, so when it comes to my personal decision making, one of the things that I look at is the more colorful a piece of the map is, the less likely I am to want to fly in that area. So obviously all the convective SIGMETs are going to be a total no-go. No ifs, ands, or buts. That's no good to go there. If you're IFR, instrument rated, and flying in those areas where there are instrument conditions today, they also have Airmet Zulus overlaid. So you have to be super mindful of the temperature at your cruise altitude today to see if there's likely chance for icing. So don't fly in an Airmet Zulu unless you are certified for flight into known icing, are current and proficient in the use of that system. Outside of that, there are lots of VFR areas today. So IFR areas, looks like it's going to be Florida, Northeast, and western part of the country. As for the VFR areas, up here in the north central part of the U.S., it is pretty windy. North Dakota down. Montana looks beautiful, really nice light winds, and Texas looks really nice as well. Showers in the vicinity later. Alabama looks good. Georgia looks good. Kind of lowish clouds, but just be mindful of that. So IFR, again, Northeast, Florida, and the West. VFR is kind of in the central part of the country, and looks like California, Oregon, and Washington have lots of VFR areas as well. Big thing with a VFR is that a little green dot doesn't necessarily mean that it's safe, right? So make sure that you're still looking at all the other hazards that could exist in the area. The biggest one that I see here is just that really strong surface wind. Make sure it's within your personal minimums, both from a total wind component and a crosswind component. I haven't seen any questions pop up from the viewers. Haven't seen anyone say if they want me to look at their route or anything. So just quickly, we'll look at, I am tomorrow taking an SR-22 from Lexington down to Tyson McGee. That is going to be for training to become a Sierra Standardized Instructor Pilot, which I am very excited about. A new venture. So my concerns looking forward into tomorrow are ceilings and freezing levels. Of course, I'm an instrument rated pilot, both current and proficient, so I have no problem flying into clouds, shooting approaches, no issue. The problem is going to be what the freezing level is in the morning. It looks like it might be a little low. So I'm going over mountains. So the minimum en route altitude, the lowest one that I could find was 5,000 over this Victor 97 airway, which is appropriate for the direction of flight that I'll be on. There is a little bit of terrain in between here and Knoxville, Tennessee, so I can't stay super low. 5,000 is as low as I would really want to go. So I would have kind of two options in the morning. One is, if the freezing level is above my cruise altitude, everything's by up some margin, 2,000 feet, everything will be good to go. Easy breezy, beautiful. If not, I might need to wait and delay my departure a little bit to allow for things to warm up before I go. So it's kind of my thought process. This far out, there's not a whole lot of stuff that I can look at. I can look at, those cloud charts we looked at, the aviation surface forecast that we looked at. I can look at TAFs to get an idea of where ceilings might be, but it's really going to have to wait until tomorrow morning to get a full weather briefing with all of the current advisory products and forecast and reports to see what's going on so that I can make a good decision. So that's my process. Okay, if there are no questions, I really appreciate you joining today for Star Wars Day. May the 4th be with you. And we hope to see you next week, same time, same place, here on AeroSafe. I hope you all have a safe week and keep blue skies and tailwinds. See you next time.